This topic of finding inverse of a matrix using the elementary operation is a little bit different than the previous topics that we learned. So that's why I'm taking one more example to find out the inverse using the elementary operations. So here I've taken a 2 by 2 matrix. Now we'll try to find out the inverse of that. So for doing this, either as I've told, either you can take the element row operations, or either you can go with the column operations. So here I'm doing it with the row operations. So let's see what we can do here. So here you get, this is the matrix A. This A can be written as IA, and I've told already, for the row arrangement you have to write it in this way. So whatever the changes here, what is our aim? Here our aim is to change this to I. We'll try to make this as an identity matrix, and for doing that, whatever change we will do in the left side, we have to do the same changes here. So after the changes, it will not remain as I, so it will become something else. So that will be B, and that B, you can say that is the A inverse. Okay, so here we will do this. Now you will see this matrix. Our first aim to make this one as identity, you can see you need here 1. So we already got 1 here, so that's a good thing. Now with the help of this one, we'll try to make this one 0. Okay, so how can we do this? See, first thing, this is the row 2 in which we need the change. So this R2 can be written as, now we want this 2 should be 0, or we want this 2 to be 0. So what we will write? We will write R2 minus. Now see, how can we do this? 2 minus, suppose if you multiply this first row with 2, then 2 minus this 2, it will become 0. So that's why we will write our R2 as R2 minus twice of R1. And now see what changes you'll get. So R1, you have nothing written for R1, so R1 will come as it is. Now R2, 2, the first row, we have multiplied the full first row with 2, and then you'll subtract it from R2. So it will become 2 minus 2, it will become 0, and then 3 minus 2 minus, and one more minus you have here, so it will be 3 plus 2, 5. And now the changes will be in this row, this matrix as well. So 1 0, first row, no changes, and then R2 is R2 minus twice of R1. So R2 minus twice of R1, so that will be minus 2, and then the third will come as it is. You can also this, if you are having problem in this, you can also think here we are taking minus 2, so multiply it with minus 2, and then you can add it. So that's why, that's way also you can do. So it will be 2 minus 2, 0, and then minus 2 minus 1, it will be 2, so 3 plus 2, it will be 5. So whatever is good for you, you can do that. Now the next thing, so here we got 1. Now here we need, this thing should be 1. So for making this 1, what can be done? Simply divide this second row with 5. So R2 can be written as 1 by 5 R2. So now here what we will get here, on the left side we'll get 1 minus 1, 0, 1. On the right side, this one is a little bit easier than the previous one. There will be 2 by 5, and here it will be 1 by. Simply you have to divide the second row with 5. So up to this I think it's clear. Now what we will do here, now we got the second row, so this is the desired row that we want, and now this thing should be 0. So how can you make this one 0? Now see, 1 plus 1 minus 1 will become 0, and 0 plus 1 will be 1. So this way you can get this one. If we write our R1 as R1 plus, here if we'll write our R1 as R1 plus R2, so you can get that one. So here 0 plus 1 will be 1, 1 minus 1 will be 0, and the second row will come as it is. And now here R1 plus R2, so it will be minus 1 minus 2 by 5. So 1 minus 2 by 5, taking LCM, you will get 3 by 5. And here 0 plus 1 by 5 is, it's 1 by 5 only, minus 2 by 5, and 1 by 5. Here you got A. So this is I and this is your B, A. So now you can say that A inverse is 3 by 5, 1 by 5 minus 2 by 5 and again 1 by 5. So that is your A inverse and that is the answer. So this we have done with the row operations.